Alright, so to understand a logarithmic function's graph, what you need to hopefully have caught when we did exponential functions, let's start with that first. If you have some exponential function, let's just make one up, f of x equals, and we'll just use some random base, well, let's go ahead and use a number, let's say 3 to the x. Every exponential function goes through the point in space 0, 1. Right, because it doesn't matter if this is 3 to the 0 or 5 to the 0 or 127 to the 0, it's always 1 when you put an exponent of 0. Alright, now if you put 1 in for x, in this case we'll get 3. Or you get whatever base you have, right? So if the base was 5, you'd get 5. If you put the base was 92, you'd get 92. Right, so then also if you put in negative 1, you get 1 over the base. Right, because that makes a negative exponent here would mean that you have a reciprocal, so you flip the thing over. Alright, so I tell you all this because if most people understand that pretty easily. The logarithmic function is the inverse function. Now hopefully from the module 2 you learned some things about inverse functions. So if I had f of x equals log 3 of x, log with the base 3 of x, then the xy role reverses. Xy reverses in inverse functions. So what was x becomes y, and what is y becomes x. Alright, so in other words, 0, 1, it's now 1, 0, because when we take the log 3 of 1, we're asking, right, this is asking, what power do we raise 3 to get 1? Alright. And we raise 3 to the 0 to get 1. Alright. So what power do we raise 3 to get 1? We raise it to the 0 power. Alright. And now, what power do we raise 3 to get 3? We raise it to the 1 power. And what power do we raise 3 to get 1/3? We raise it to the negative 1 power. Alright, so that's a basic logarithmic function with no, and again this is also important, both of these are with no shift. Alright. And another little nuance we need to point out is that an exponential function has a horizontal asymptote. Alright, if it's not been shifted. And that horizontal asymptote is through the line y equals 0. Alright, well guess what happens in an inverse function? Instead of horizontal, it's now a vertical asymptote. And instead of going through y equals 0, it goes through x equals 0. So everything, like I said, is totally reversed. Alright, so in this function, they're showing you here that the vertical asymptote is at x equals to 0. Alright, so we know what that means is there's no shift left and right. If that asymptote moves, you have some left to right shift, right? But this means there's no shift left to right. Alright, so now the function should go through 1, 0, but it doesn't go through 1, 0, right? There's 1, 0. It looks like it goes through 1, negative 1. And it should go through 3, 1, but instead it goes through what looks like, I'm sorry, what base is this? What doesn't, well, all these have a base of 6, so in the case of this problem, we're doing a 6, right? So it should be a 6 here, and a 1 over 6, but it doesn't go through 6, 1. Right, if you go over 1, 2, 3, 4, 5, 6, it goes through 6, 0, it looks like. Alright, so in other words, what's happened here is these red points are, it should be up here, right? It means that this thing got shifted up 1, or shifted down 1, right? The point should be where the blue dots are, but they're where the red dots are. And so, when you take a function and you hang a -1 on the end of it, that's when you shift things vertically down. That means go down 1. Right? And notice the difference. There's a difference between this and this. This one, the -1's inside the parentheses. So that's why the answer is A. It has a vertical shift down 1.